All right, everyone, it's Mr. Rops here, and so we are going to be talking about the absolute value family of functions. And just to recap, we've done the quadratic family, we've done the linear family, we have done the square root family as well. And so now we're going to talk about the absolute value function here. And it is defined by these two straight lines that on either side of the x. Okay, so the parent function g of x is equal to absolute value of x. So what does that actually mean? Well, what it actually means, if I'm going to do, it says its job is to make things positive. Okay, so if I would go g at 3, you go the absolute value of 3, well, that is going to be 3. But if I was going to do g at negative 3, and I do the absolute value of negative 3, it says, oh, make me positive, make me positive, make me positive. That becomes 3. The positive 3 was already positive, it stays that way. The other, so if I would do g at negative 10, well, that's going to be the absolute value of negative 10, which is positive 10, and so on and so forth. The other way that people can describe it geometrically, what the absolute value function does, is it considers the distance away from 0. So here's 0, and if I'm going to find negative 2, here's negative 2. This distance is a value of 2. So the absolute value of negative 2 means the distance away from 0 is 2. Similarly, if I had 5 here, what's the distance away from 0 of 5? Well, that is also going to be a positive value. So whether you think of it as distance or if you think of it as a job as the make positive function, either way works. That's its job. It takes values and it makes them all positive. Once you've done the operation of the absolute value, then it comes off. And so what does the graph actually look like? Well, let's start with a table. Here's x, here is g of x. And so I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, 3. And so if I do the absolute value of negative 3, well, we know that's 3. Absolute value of x is positive 2, positive 1, 0. The absolute value of 1, I plug it in. It says make me positive. It's still 1. It's still 2, and it's still 3. And so then if I'm going to come along and make my graph of that, I'm simply going to get values that I'll start here at 0, 0, 0, 0, and then 1, 1, 1, 1, 2, 3, 3, 3. That's these ones here. And then I'm going to go negative 1, negative 1, 1, negative 2, 2, negative 3, 3. And so what I get is I get this nice V shape. Okay? If I go to Desmos, I just go y equals, and I can type ABS in parentheses x, and that will do it. And you can see how it's that nice V. Or I can also go y equals, and on my keyboard, it's above the / button, x, and that will also do it as well. And then you can see the absolute value function here. And so it has some of the new things. The key point is what we call our pivot point. It's like the vertex. This is the pivot point, 0, 0. It's a vertex. The x and y intercepts still 0, 0. The domain, x can be any number. However, the range is all above the x-axis, so y is bigger than or equal to 0. Now, there is an inverse that exists, but you are not responsible for this in this particular course. You do not need to know about the inverse of the absolute value function. So there is your quick introduction to the absolute value function and its family.